In today's video, we're going to talk about how do we simplify logic circuit. There are a few concepts we need to go over, something like minterms and sum of products. Maxterm and product of sum. We also need De Morgan's law, which is De Morgan's theory. And also we use the K-map to help us do the simplify. So let's say if we have a truth table, something like this, change a different color. We have something like this. So for the minterm, it will be the combination that give us the result of ones. So we only look at this is the kind of the output or the result. We're looking for the row that give us ones. So like this one, we have this one. So these are the ones. These are the ones. So basically for the output, we have 3 ones. The term is like if we have 0, we just write down like a negation if it's 0. So that would be, for that would be a bar times b times c, that will give us 1. For this one, it will be a times b bar times c bar, that will also give us 1. For this one, the last one, it will be a, b, c, give us 1. So these terms are the minterm. And we can write the result in, for the OR gate. If we have 1 is true, the result will be true. So we can write the sum of the product. So basically, since these are the multiplications, that's the product form. Now for the total result of y will be equal to so for the total result, y will equal to the sum of the minterms, or the product, plus a. So the result will be a times b bar times c bar plus a times b times c. So that will be the form of a sum of product. So this is a sum, and these are the product, sum of product. So we get the product, which is the minterm, the rows that give us ones, and we add them up in order to get the result for the output. Same thing for the maxterm, we're looking for the rows that give us zeros. So for the zeros, we'll have this. If we have the same truth table, so that'll be the same zeros. These are our zeros. So we gotta write in the sum. So it will be the product of sum. That will be, so our maxterm, the maxterm is kind of something are all of the combinations that give you the result of 0. So we're looking for the result at 0. For example, for this one, the first one is A, B, C. So A plus B plus C. For the first one, it's the max term. And for the product of sum, it's just we find all the rows that give us 0 and find all the combinations. So for all the max terms, from the truth table, that would be A plus B plus C. We also have A plus B plus C. C bar. And the 0 will be A plus B bar plus C. And A plus B bar so I already get that one. So we're looking at this one right now, so it'll be A bar plus B plus C bar. This one will be A bar plus B bar plus C. When it's 0, it's 0. So the result in the product of sum so we write all the sum in product form A plus B plus C. Put bracket there, and A plus B plus C bar, A plus B bar plus C, A bar plus B plus C bar, A bar plus B bar plus C. So basically we need to find all the max terms, which is the row gave us the 0. And then after we collect all the max terms, we write the output in the form of product of sum. So when it's 1, we write in the form of a B bar. When it's 0, just kind of the way it is. And just a basic review, so if we have AND gate, we'll have y equal to A times B. If we have OR gate, y equal to A plus B. If we have a NOT gate, y equal to A bar. And the equals is one or the other. A equals B. One or the other, but not both. And there are some Boolean laws that can help us simplify the circuit. So the first one we talk about is the law of identity. So we have A times 1. If we think about a mass, so A times 1 is basically itself. Whatever times 1 is 3. 3 times 1 is 3. Same thing for the logic gates. A times 1 is A. And if it's A plus 0, whatever plus 0 it is itself. So that's 3 plus 0 equals 3. So A plus 0 equals to A. That's law of identity. We also have the second one, law of intersection. So that would be A times 1 equal to A. A times 0 equal to 0. Same thing, think about math. 3 times 1 equals 3. Whatever times 1 it is itself. Whatever times 0 will be 0. We also have law of union. Which is A plus 1 equal to 1. Select OR gate. So we have OR gate, but the other switch is always closed, always 1. So if we have light here, the light is always on. So A plus 1 equal to 1. It's kind of like OR gate there. And A plus 0, which is A. The result will depend on A. Since the other one's always open, OR gate. And this one's always 0, so this one's always open. So they never give us 1. So the result will be based on the first one. If this one is closed, the light will come on. If the light is off, if the switch is open, the light will go off. Won't come on. We also have idempotent law. Idempotent. So be A times A equals A. So let's say if 0 times 0 will be 0, 1 times 1 will be 1. That's what it means. A is something times itself. Because it's kind of in logic circuit, it's a binary. So we only have zeros and ones. 0 times 0 is 0, 1 times 1 is 1. A plus A will also be A. So it's like 0 plus 0 is 0, 1 plus 1 is 1. Or same thing, OR gate, if both close, the light will come on. We also have a complementary law. Complementary. Complementary law, which is A times A bar equals 0, A plus A bar equal to 1. So if we think about, so A can only be 0 or 1. So if A is equal to 0, it will be 0 times not 0, which is 1. 0 times 1 would be 0. And when A equal to 1, that would be 1 times 1 bar. So 1 times 0 will be 0. That's what it said. So A times A bar equal to 0. And for this one, same thing, zeros and ones. When A equal to 0, 0 plus 0 bar will be 1. When A equal to 1, we already have 1, so 1 bar will be 1 plus 0, still 1. That's why A plus A bar equal to 1. We have a double negation law. Double negative, so invert twice, so A double negation will equal to itself. So if we have, let's say if when A equal to 0, we have 0 negate. So if we do the first negate, it will be 0 negate will be 1, 1 negate will be 0. So it is equal to itself. When A equal to 1, we have 1 double negation. So if we do the first time, it will be 1. So it will be 0 negate. 0 negate will be 1. So it's still itself. Double negation will just give it itself. It's kind of thinking about negative number. Negative 1 will give us 1. Negative will give us positive. Something like that. And we have a commutative law. Commutative law, which is A times B equal B times A. It's like 3 times 4 equal 4 times 3. And A plus B equal B plus A. Same thing, 3 plus 4 equal 4 plus 3. It's kind of like math itself. And we also have associative law. which is A times B bracket times C equal to A times B times C. So basically this is kind of like 3 inputs AND gate. Doesn't matter if you do Z2 first or Z2 first, you still need to combine the 3. So Y equal to A times B times C. You can group AB together. You can also group BC together. Same thing for the addition, A plus B plus C. If we put bracket here, equals A plus B plus C. It's like 3 inputs OR gate. We can do AB first. We can also do BC first. But the total result will be A plus B plus C. That's also associative law. Distributive law. Which is A times B plus C equals A times B plus A times C. It's kind of like 3 times 4 plus 5 equals 3 times 4 plus 3 times 5. And we also have A plus B times C, which equals A plus B times A plus C. This one doesn't have anything like math here. We cannot say 3 plus 4 times 5 equals 3 times 4 plus 3 times 3 times 5. There's nothing. This will be plus. There's nothing in math like that, so they don't equal to each other. So this one's kind of a special. A plus B times C equals A plus B times A plus C, distributive law. We also have De Morgan's law. Which is the product negative equal. If you change the sign, so it will be A plus B negated equals A negated times B negated. So you change the sign, break the line. So A plus B negate equals, change the sign first, then break the line here. That's how we break the line there. And same thing for A times B negate will be, we change the sign first from product to sum and break the line on the top there. Change the sign. And break the line. Step 1, step 2. That's how De Morgan's law works. So we also have law of absorption. Which is A times A plus B equals A. So from here, if we have A times A plus B, it will be A times A plus A times B. A times A basically is itself. And A plus B, let's say, now we change it back, it will be A1 plus B. 1 plus B is always 1, so it will be A. I always try to think in something in math. So A times A plus B, if we use distribution law, it will be A times A plus A times B. And a times a is kind of just a itself, because there, let's say if a is 0, 0 times 0 is 0, 1 times 1 is 1, so it's always itself. A times a is a, and after that we can just thinking a times 1, and we can call the common factor a, so it will be a times 1 plus b. 1 plus b basically is our OR gauge. 1 plus a equal to a. That's the formula we use. So 1 plus b will just, sorry, this is a 1. So the result will be a. And same thing for addition, a plus a times b. So we just did this one from here, so it'll be just a itself. So these are the kind of the common laws we use, or the common theory, the formula we use in order to simplify the logic gates. So whatever we have, a Boolean expression, whatever we have, we try to group them together as much as possible. That means simplify. And for the K-map, it's just another way help us to simplify the Boolean expression. I say if we have a truth table, truth table, something like A, B, this is our output. Since we have 2 inputs, there are only 4. So we have 0, 0, 0, 1, 1, 0, 1, 1. The output is 0, 1, 1, 1. So let's say if we have something like this, and we need to build the truth table by writing K-map first. So the K-map will be, so we have A bar A, which is 0, 1, B bar B, 0, 1. So this is a kind of how we build the table here. After that, we have 4 places to write down the truth table result. So these space are for the space here for the result y. So when A is 0, B is 0, so we have 0 here. When A is 1, B is 0, we have A is 1, B is 0, we here, so we have 1. When A is 0, B is 1, A is 0, B is 1, we're here, so we have 1. When both A and B are 1, the result is 1. So we have something like this. Now we, based on the map, we just kind of group these together, group this guy together. The common ones, so y will equal to a. So this one, the common is a, this one's b. Because no matter what b is for this column, the result depends on a. So if a is 1, the output is 1. Same thing for this one. When b is 1, doesn't matter a, the result is 1. So the result will be a plus b. That's how we use K-map to simplify. We try to group the common factors, the common ones. Let's look at another example for the K-map. Let's see if we have Another truth table, let's see if we have 4 inputs truth table. So you have A, B, C, D. Output is Y. So 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1. That's 7. 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, have 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. So these are all the inputs we have. Say if we have the result 1, 0, 0, 0, 1, 5, followed by 5 zeros, and 1, 1, 0, 0, 1, 1. So let's say if we have something like this, this is our truth table, and we need to build the K-map for it. Let's say we have C bar, D bar, C bar, D, C, D, which is 0, 0, 0, 1, 1, 1, 1, 0, C, D bar. And we have 0, 0 here, A bar, B bar. We have A bar, B. We have A, B, A, B bar. So sometimes based on the output, we can change the order of these inputs. So when we have, let's start from the first one, it's A bar, B bar, C bar, D bar. We only look at the rows that give us ones. So this will give us 1, 1, 1, 1, 1, 1. So for the ones, we have A bar, B bar, C bar, D bar, which is here, 0, 0, 0, 0, 1, 1, 1, and 1, 0. These are inputs for A, B. These are for CD. Ones is A bar, B, C bar, D. So it's A bar, B, C bar, D bar. A bar, B, which is here, C bar, D bar, which is here. That's also 1. And from here, it's A, B bar, C, D bar. So A, B bar is here, C, D bar is here. So that's another one. This one is A, B bar, C, D. A, B bar, C, D, which is here. This one's A, B, C, D bar. A, B is here, C, D bar is here. Sorry, no. C, D bar is here. So A, B, C, D bar is here. Last one's A, B, C, D, which is A, B, C, D is here. The rest is just zeros. Can fill out with zeros. Now we can group the ones. So we can group these two. Just do this. And group these 4 together. That way, that's how we group them. When they symmetric or kind of together, have a common factor, we can group them. So the result for this one is, so our final y equal to, from here we can get, so the common factor is A bar. So we have A bar, and also on this one, C bar, D bar. So these are 0, we don't have something like that, so we don't even look at here, we only look at these 4, so we have the common factor. It's A bar, C bar, D bar. And by looking at it here, we have C. D bar is different, so we have C. And A. A is also the common factor, so it's A times C. So we have trying to find the common factor for these 4. So we look at these 2 columns and look at these 2 rows. It's a common factor for these guys. So it will be C and also A. So the result is A times C. So by looking at the K-map, sometimes we just need to figure out how to group the ones. If necessary, we can change the order of the input, like A, B, C, D. We can, in order 0, 0, 0, 1, 1, 0, 1, 1, we can write down the order is 0, 0, 1, 0, 0, 1, 1, 1, something like that. We can always change the order. That way, if that can give us more ones together, if we can put that will just help us simplify the circuit more. Alright, this is everything for today. Thank you.